This is section 9.5, graphs of quadratic functions. A general quadratic function looks like this. F of x is equal to ax squared plus bx plus c. The only difference in between what we have right here and what we've been dealing with is that this is a function right now. Okay, it's not equal to any particular value. All right, so the most basic requirement in order to be called a quadratic function is that you have an x squared. All the rest of this could be missing. The number in front here, it could be a 1. We can't have an x cubed. This needs to be the largest exponent, but the most basic, the only absolute requirement is that we have an x squared. What we're going to do first is we're going to talk about the graph of f of x equals x squared. So our most basic parabola is what this shape is going to be called. We're going to be talking about how we can take this basic shape and we're going to be moving it around in order to get new graphs. And what I want to do first here is I want to just do a t-chart and I want to get this most basic parabola graphed, okay? So if I take 2 and I plug it in here, 2 squared is 4. So I would have the point 2, 4, okay? If I square 1, 1 squared is 1. So that means I have the point 1, 1. Okay, if I plug in 0, 0 squared is 0. So I have the point 0, 0, which is right here. Okay, so if I plug in -1, this means -1 in parentheses squared. So that means this is a positive 1, and I have the point -1, 1. Okay, now if I plug in -2, this is -2 in parentheses squared. So I would get positive 4. And then, so this is -2, 4. Okay, now what I'm going to do is I'm going to connect these points in a curve. Now, I don't expect you to be an artist. It's not going to be beautiful, chances are anyway. But it's going to look something like this. You want to do your best to make sure this is a curve at the bottom here. It does not come to a sharp point. Okay. Okay. So this is the basic shape of a parabola. Everything else we deal with in this section is going to be based on this basic form. What you really want to be able to do is you want to be able to reproduce this particular graph very quickly. And if you just remember these 5 points, it will help you out a whole lot, okay? Because if we can figure out how to get these points placed, we can get the other graphs quickly. Now, if you want to remember some extra points, and I used them when I did this graph, 3 squared is 9, -3 squared is also 9, okay? So if you want those extra points, you can use them. One thing to recognize is that this thing is symmetric about the y-axis, meaning if I could fold my graph on the y-axis, my points would line up, okay? Another little bit of vocabulary is this point right here where our parabola changes directions. That's called the vertex of the parabola, okay? So let's talk about our first kind of shift, okay? This is a vertical shift, and I have it labeled in the outside, but that might not make a whole lot of sense to you just yet until you can compare it to what I call an inside. So don't worry about that just yet, okay? And this says, the graph of f of x is equal to x squared plus k. So this plus k is the new part, okay? This is what we just grafted, that's a good word. That's the graph we just did, and this is the new part, okay? It's going to be a parabola with exactly the same shape as the graph up here. Okay, but it's going to be shifted vertically up if k is a positive number. So if we have x squared plus a number, it's going to go up that number, okay? And if k is a negative number, which is going to look like x squared minus a number, then we're going to go down by that number, okay? The vertex, which is where the graph changes directions, will be at the point 0, k. So whatever this value is, whether it's positive or negative, that's going to be the y value for our parabola. Okay, so let's look at some example problems. Okay, I want to find the graph of the following functions. I have f of x is equal to x squared plus 2. The formula from the other side, the other page, was f of x is equal to x squared plus k. So in this case, our k value is equal to positive 2. So since this is a positive number, we're going to take our original graph and we're going to move it up 2 units. Okay. Now one thing I've done is I've taken our original graph and I've copied it onto some tracing paper so we can see a little bit what this looks like as we do it, and then I'll make a better graph showing you how to do it on paper easily. Okay, so this is the original x squared graph. What I'm going to be doing is I'm going to take this entire graph and I'm going to shift it down to, no, not down, up 2 units. So my new graph is going to look like this. Okay, now look what happened. Each of these 5 points, if we just take those 5 points, which are here, and we move each of them up 2, we have our new graph. That's all we're going to be doing here. What I do when I first start off learning how to do this is I do what I call ghosting. I'm going to plot the original 5 points for the original parabola. This is not part of your answer. Okay? So imagine doing this very lightly with your pencil, and you want to get this graph of this, and you're move it up 2 units. So I'm going to take this one and move it up 2, move this one up 2, this one up 2, and then here. And now connect your green with as smooth of a curve as you possibly can. And you have your new graph. Okay? All right, so let's try a different one. If I have x squared minus 4, again, this is f of x is equal to x squared plus k. Well, this is a minus sign, so k must equal negative 4. Since my k value is negative, this means I'm going to take my graph and I'm going to shift it down 4 units. Okay, so again, if we think about this as on tracing paper, okay, that's my basic graph, and I'm going to take this and slide it down 4 units. And you can see that just by taking these 5 points and shifting them down, you can have your new graph. That's exactly what we're going to do again. I'm going to ghost my original 5 points, and you should get very quick at reproducing these. Okay, and then I take each of them and I move them down 4. So this one comes down here, this one's here, 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 and here. And then you graph your new parabola as smoothly as you can, and you have your new graph.